The following is a presentation of Nova Hackers, brought to you by ComputeCycle.
Alright, so my name is Nate Guagenti. This is my third time here, so I'm doing a brief introduction and then a presentation on Passive DNS system that I built. Call it finding a needle in a haystack. So I'm 23 years old. I just moved down to Nova January of last year from Columbus, Ohio. I've been working in IT for 5 years now. First 3.5 years I was kind of like a SME for small business. Did like server deployments, Active Directory, firewalls, VPNs, things like that. Then for about 6 months I traveled back and forth from Columbus to DC to work on the 802.1x rollout, and then last year I started working as an IDS analyst, and I was working mid-shift, and so a lot of the events were mostly cleared out by the people on days and swing shift. So essentially I was left to just parse bro logs all night, and this is kind of where I came up with the idea. Besides working on computers, some hobbies I like, or some hobbies I'm involved in, is being engaged, which takes up 75% of my time. I just got engaged in January, getting married in August. We had what's that?
We could get married next. The whole
I mean, we had the place and the date picked out within a week. I don't know if she had been waiting, waiting for somebody to ask her and had all those things picked out. But so yeah, spending most of my time with her, and then play basketball and fish. So, but most of the time I spend on a computer. So to talk a little bit about the database, some of the things it does, it includes Alexa rank, which I don't know if you all are familiar with or not. I'm sure most of you are, but just a ranking of the top 1 million sites. Pulls in some whois information, such as the creation date. Looks up country code. So if the query response of a DNS lookup was US or RU or Brazil or something like that. Couple of things I didn't get to implement. I know you're not supposed to discredit yourself in a presentation, but 4 months ago I started creating this. I built it in Mongo. I've never been a database programmer, never built a web front end. The most I did in Python was read lines in file and then parse it. So there's a lot of work that needs to be done in this, and then also I'm doing most of this in my spare time and then some of it at work. So it's not 100% polished, but some future implementation will have ASN numbers, like Passive DNS from VirusTotal, which I had the back end written for VirusTotal to scan each domain, but it only allows you 4 queries per minute. So essentially, just to bypass that, I'm going to create a couple API keys and then thread the lookups. But getting the Passive DNS from VirusTotal for free shouldn't be a problem. I don't think they rate limit you for that stuff. But so I guess just essentially this is just a live demo. Just going to start off with a couple simple queries and then work my way. What's that?
Can you make the font bigger for us to look at?
Yeah, the only thing is, once it gets into the actual, the results, some of them I have to scroll left and right, which I hate doing. But let's say 2 mouse buttons on a mouse, But anyways, so just start off with a couple things simple. So Alexa rank equals 1. If it's gonna come on, man. So the reason it's taking so long is this polling. Since Alexa rank is based off the first and second level domain, it's going to give you every result that ends in google.com. As you can see, that it only took 1/100th of a second to actually return the results. And then the rest of the time is actually just Firefox rendering the page. As you can see, this is when it started. the actual query and everything, and then this is when it stopped. So the rest of it is just Firefox returning the results. And I'm currently limiting it to 1,500 records just because I've spent like 5% of my time on the front end interface and most of it on the back end to improve, you know, the time it takes to query and just the naming and things like that. So, but essentially that's easy. You just skip, so you don't have to limit. You just skip, say, you know, first 500 results on, you know, link 1, second 100 or second 500 on link 2. I just haven't implemented that. So then, you know, country code equals RU, right? And then everything over here is clickable. So a query response, I don't know if anything's going to be hosted on this same IP address, but those are clickable. And there's not, but so then, I mean, you can click the other country codes in here. Essentially, I had to, some of the times, you know, whether it's blocked or for whatever other reason, there might not be a result. Or in this case, this returned another domain name, so obviously that's not an IP address. But then it tells you the clients, you know, that looked that up, the servers they looked it up on, the ports, first time it was seen, the last time, query types, you know, response codes, protocols, and then the time that lives for all those domains. So then, I'm trying to think of another one we should do. Let's do, let's see. So, let's see here. Give me a second. I'm trying to think of another just basic query. Let's just So these are just basic examples to show you. Obviously you can search by the port. So I know another port. Yeah, so it's 5353 port. I mean, then you can look for, you know, DNS requests not over 53, and then working on an HTTP database too. You probably want to know any HTTP not over port 80. Obviously, there's other common ones like 8080, and then, you know, stuff like Neutrino exploit kit commonly uses 8000. And the environments I've seen, there's maybe, you know, 2 requests in a month that aren't malicious over port 8000. So then you can also do regex with some of these fields. So you know, let's just do, trying to see here. I can't think of a regex right now. Just, again, this is just ending in RU. But I have even better than that, just the first level domain. I decided to use LD, not because I have a learning disability, but just because it's just a simpler format. Instead of level domain, or then first level domain, and then second, third, and fourth. Some people call them top level, you know, some people call them GTLDs, you know, I don't know, it's just easier for me to do that. So to do first level domain, you know, you can do first level equals RU. Again, you have all the results. Let's see, can do host length too. So, and then it has every second level domain, so second level equals Google. Again, this is going to take a while because the results of Firefox. Right, so here again, Google again. So, and then you can see the second level is Google, and this obviously it's more returning than just .com. So we can exclude .com, and so we're excluding first level domains that end in .com. So, you know, you got Google SE, Google Netherlands, it's an incorrect search, etc. Then you can do the length. So this is first level domain length greater than 4. Yeah, greater than 4. And a lot of these things don't have regex validations for the domain, because recently, in January or something, they just approved, you know, .cab, .cat, you know, .best, .free, you know, all these other different first level domains. So obviously this one down here is going to have things like that. So it's just easier to just write a regex that didn't worry about the last domain.
Could you do a query looking for something where the second level contains Google, but it's not equal to Google?
Yeah, exactly. So I don't have contains in it, but that's yeah. So that's where the regex, yeah, .star, Google .star.
But not equal to Google. That way.
Not, yeah.
Anything where Google.
So here, all right. So this is actually one of the queries I built, one of the spoof Google domains. So right here, we're just doing host equals Google. So anywhere with Google in the oh, sorry about that. Completely forgot. Anywhere with Google in the domain name, exclude ending .edu. These are all the other domains I've excluded. Couple first and second level domains, and then some first, second, and third level domains combined. So we're going to run that really quick. And then I don't know if anybody here does Mongo programming. RoboMongo is a great interface, GUI interface. Obviously, if you're elite, you do it from the command line, but it's just easier to visualize this way. So we're going to run this query. All right, so it took 2 seconds to run this query. Then this is the native Mongo query. I've included this just for myself, you know, doing troubleshooting sometimes. Go ahead.
I think I missed something early on. What data set are you querying against here? Is this like a collection of row logs that you gathered and then you fed it into your tool?
Yes.
Okay.
Yeah. So I actually only have one environment right now. This is probably only like 50 computers. I do that just for fun, just some data to use, so I don't have to take data from my environment at work, home, stuff like that. But at work, I think it's close to like 700 or 800 computers, a lot more devices than that. But that's just like actual end user devices. So does that answer your question?
Cool, yeah, thank you.
Okay.
From the DNS server, or is this in the data?
Yeah, so these are running off spans and taps. Eventually, yeah, these are running off spans and taps. So and then this is just essentially it's this like all the bro logs are in a text format in a CSV with an 09, whatever tab is for hexadecimal, but they're tab delimited, and so it's just running through each one of those files. Eventually, I'd like to program it actually into Bro, so it's running live. But I mean, this works. So I'm gonna skip down one of the ones I found. Let's see here. So right here. So you can tell some of these are pretty suspicious. I mean, just by having Google in it, and then some of the other random characters in there. So they can click on this, see the other domains, see that they're also trying to spoof YouTube. You know, like some of the other ideas that I had with this. So FireEye released a report, like March. They had a website, was aadserver.com. So it's aadserver.com. I don't remember what exploit kit, or was it a 0-day or not? Maybe somebody can correct me. But anyways, they were able to find, they found out that it was malicious, targeting some new exploit, and it had been created, you know, 30 days before they had found out. So you should be able to know, you know, like give me all the domains that have been created in, you know, last year, or give me all the domains that my computers have looked up in the last 10 days, you know, and then be able to know how many times they've looked that up, you know, first time and the last time, things like that. So
one cool entry that you can pull with that is you can pull the whois information.
Yeah.
By pulling the whois information, you can pull when it was created, and you can also pull the email address of the user.
Yeah. So I have the creation date right now. I actually just implemented the creation date last week, and I've been out of town. I just got back from Columbus, Ohio this morning. So I actually didn't have time to let it run, because the querying I was doing against the who is online, they rate limited me, so I figured out that if I sleep for 5 seconds after each lookup, so I had like 60,000 domains to look up, and that wasn't enough time to run through every domain over the weekend. But I'll show you some of the queries. So all right. So I mean, obviously you can do, you know, the non-existent domains. And then so here's another one. This is just 6 consonants in a row. You know, usually you should have some sort of dictionary words. And then I also don't have you're probably gonna hear me say that a lot right now, but an entropy based off of dictionary words, the length, and then it kind of calculates an entropy score. I just didn't build the front end to that, and I hadn't let it run through all my data. So again, you have a couple non-existent domains in here. And this database really is only going to be as good as the person that uses it. Obviously, you can create a couple automated queries of, you know, every time I have a new domain created that's looked, or, you know, every time a domain has been created in the last week and has been looked up, you know, feed it into a sim or something. You know, maybe 6 consonants in a row with no vowels, obviously, you know, feed it into a sim. But a lot of times this is going to be good for historical purposes. You know, you just figure out a C2 domain for, you know, an adversary, or, you know, just regular bad malware from, I don't know, Russian mafia or something. You know, go back, check it. Don't have things like, maybe easy to implement pulling, you know, the domains down from malware domain lists. And then I have a list of like 60 other open IP/domain reputation sites that you could feed it in here. In the environment that I work in, we have, I think, maybe like 8,000 domains or something that we monitor, that I query it often to see if any of those domains have been looked up, that we have attributed. And then so then a couple of these another thing that is on my to-do list is tagging. So after you've already looked up a domain, being able to say this is a C2, this is benign, you know, this is just adware, spyware, whatever, the different tag categories, so you don't have to constantly get the same results. So again, this is the 6 consonants in a row with some whitelisting. So again, this took half a second to respond. Obviously, it's found 2,300 records, so a couple of results. But again, Firefox is going to take a while. And I've actually crashed my entire computer a couple times before I learned that I needed to limit the amount of results returned.
Chrome is a little more forgiving on that.
Is it?
Yeah.
Okay.
I got a 2-part question for you.
Yeah, go. You guys ask me questions all I want. This is probably boring, somewhat boring.
First,
Oh, sorry.
so you did mention the fact that some of them are returning IP addresses, they're returning other domains.
Right.
Would that be placed in implement?
Yeah. Yeah, it's on my to-do list. So I have a Trello board. I don't know if anybody here uses Trello, but I got, I don't know, like upwards of like 200 action items to do for the database. I mean,
Part 2.
but so you're saying like pull it and then see, like, so this, and then look it back up in the database. Yeah, exactly. That's
Part 2 is the really interesting part, though.
all right.
So have you heard of deep magic?
Negative. No.
About Fuller is physics?
Yeah, I'll just say no.
Something called deep magic, where he basically reversed DNS to the internet.
Okay.
I'm kind of not kidding when I say that. You'll probably get some really cool ties and leave the two together.
Okay.
IP reverse DNS to see what's going on.
All right. So is that what is it? Do you know what it's querying? Like, is it doing a lookup from that computer, or is it?
It is magic.
So is it?
I'm guessing you distributed the workload and then just PTR lookups, like brute force enumeration, whatever you see.
Okay.
PTR range.
Okay. I didn't know if you just looked it up on the active DNS servers, or he had some database like or whatever. So.
Well, we're going right now.
Okay.
But this is a cool idea. So he's looking at bro logs, looking for stuff that comes back up, and he thinks it'll look nefarious. Thought it would be fairly interesting data set to kind of take whatever this thing spits out, the IPs, and throw it in deep magic. See if there's any other things to look at. So
I already have a bunch of people working in the deep magic for past IPs. So malware researchers will say, hey, this DNS thing resolved to 127001 right now, but it did resolve to a week ago, 5 days ago. If you're asking do I have any guide for that, yes. How far back? 2009.
All right, so then I'll show you, so the creation date, this is one of the last things. So I actually have the actual creation date and then subtracting the day it was created minus the time it was looked up. So this is just days after creation, and we'll say all domains that have been looked up in the last, or if it's 20 days, if the domain was looked up 20 days after it was created. And then I've looked up a few of these. I'll try to see if they're in here really quick, because I'm not going to sit here and try to parse it. So yeah, here's one. This Besta's software. Just show you. All right. Well, hold on. Maybe it's the wrong one. Yeah. So, I mean, you can see it's hosting some other malicious domains on this same IP. Obviously, one looking at like it's trying to spoof YouTube. And then, so there's Phil's one, which is that, yeah, that's in there. Guess I just have the link. So again, this is hosting some crappy stuff. And I mean, you know, again, this is only as good as, for the most part, as the analysts use it. You can get creative. Obviously, it's been created in the last 60 days. You know, and Alexa rank is 0. So I chose the number 0 for no rank. So this is filtering out anything that doesn't have an Alexa rank. You know, I have some other queries built, but again, DNS logs are not boring, but I can't, you have to like take my word for it, or I have to show you that it is malicious based on a website online. And again, you know, in the future, having the HTTP, obviously being able to use regex, obviously there's things like URL query, which you can use a regex to look at other websites. But, you know, say you had, for example, you know, the Zeus use gate.php, being able to go back, look up every, you know, every HTTP request in your environment that has hit that URI. And then having the Alexa rank and the HTTP, being able to filter out post requests. You should be able to know all the post requests to, you know, different domains. You know, first time that post request has been done to that domain. And then filtering it out with Alexa rank and things like that make it easier. But I guess, does anybody have any questions? All right, cool. That's it.
This has been a presentation of Nova Hackers, brought to you by Compute Cycle, a Cranial Thunder production.